right, so let's talk about cognitive styles. This is something we have not addressed yet in this class, and that's the idea that people think differently. One difference in cognitive style might be how impulsive or reflective a person might be. This picture that I selected is trying to indicate an impulsive style where, before the teachers even completely ask the question, the eager child has their hand up, they're ready to answer it. Maybe you've seen Family Feud, and before the host has even completely read the question, somebody hits the buzzer because they want to get in early, and come to find out, had they listened to the rest of the question, they would have realized that the answer that they impulsively gave doesn't fit. So some of us are more impulsive, some of us are more reflective. We want to hear how the whole question goes. We want to see how this whole thing pans out before we react. So this is something that we start to see very early in childhood, probably 7, 8, 9 years old. We can start to tell the impulsive thinker from the reflexive thinker. So this is one difference that we might see. Another is a difference in people who are field dependent versus field independent. When I was a little kid in the olden days, when they used to have a newspaper that would be delivered to your doorstep and people actually subscribed to it, my parents got the newspaper, and on Sundays in the comics, there was this little hidden objects thing. It had a name. I can't remember what they used to call it. And they would tell you all the little objects that were hidden in the picture, and you were supposed to search through and find them. Giving you a second to see some things that don't fit in this picture, and those were the things we were supposed to find. Like, using my little arrow, I'll point out that there's a little sailboat on the thigh of the creature that's holding the local newspaper. There's a little heart on that creature's chest, right? Like, these are all the objects you were supposed to find. You can see up here on the books in the background, it spells out the word mini, and that was always hidden. Mini page, I think, was what was hidden in there. It was for like the little kids to have something fun to do in the comics. I don't know what else we're looking for in this picture, but it looks like this object on the bottom that the mouse is sitting at might be an old-fashioned iron. I'm not sure if that's true or not, but that's the kind of thing you're supposed. Oh, here's a little hidden key, an old like skeleton key. So you're supposed to find all these hidden objects, right? Some people are much better at a task like this. Some people are much worse at a task like this. Oh, I just saw some lips on this arm of this creature that's holding the newspaper. People who are field dependent look at the whole. Oh, I just saw a candy cane too. Look, there's a candy cane coming up from his hand. People who are field dependent look at the picture as a whole. And they get the theme of the picture, that there's a creature holding a newspaper, there's a cat sitting there reading a newspaper, there's a mouse sitting there reading a newspaper, that they get the big theme and they get the basic pattern. And the little details are not really that important, because what I'm here to look at is the whole field. And so field dependent people understand what they're looking at in the context of all the other stuff that's around it. Like, they get the whole big picture. Field independent people, the big picture doesn't distract them as they're looking for these little elements that make up the picture. So a person who's field independent would probably find these hidden objects faster than a person who's field dependent. Now, to test this psychologically, we usually use something called an embedded figures test. Here's a variation on a very simple version of the embedded figures where, I don't know if you can tell, but there's a bunch of cubes in there, a bunch of squares in there, where the upper left part is a white triangle and the lower right part is a gray triangle, and there's a grid of 9 of those all placed, and then you're told to look for a rectangle in that object, and so they've outlined the rectangle for us. There's probably multiple places that you could circle and find or you could put a line around and find a rectangle. This is where they marked it. That's an embedded figures test, and it assesses field dependence versus independence. This is a really simple one, so hopefully you would all be able to find the rectangle in amongst those triangles. They get really complex. And when I was working on my PhD, we did a study that included the embedded figures test, and it goes from simple like this and black and white to colorized. And this was back in the early 90s when color printers were not a thing yet. I mean, if it came to you already colorized, it was really expensive. So they would send us the materials, and then we had to use felt pens to colorize the parts that were supposed to be different colors. And so we're given a key, and we're told, okay, color this part yellow, color that part green, like that. So I was sent home with my little embedded figures, and I was supposed to color them that night because, nothing says a nice 28-year-old working on a PhD like a coloring assignment, but okay. So I'm home coloring my things, and I got to there's like 30 of them in the test, and I was on like item 29, and I was supposed to be finding this triangle and color the whole thing yellow. But the triangle overlapped a whole bunch of different objects and shapes in there, and I was supposed to find the triangle, and I'm like, I cannot find this triangle in this figure to save my life. I was staring at it, rotating it, trying, sometimes if you look at things upside down, they'll pop out for you, things like that. I could not find it. I had been coloring all afternoon anyway. My husband comes home from work. It's like 9:30 at night or something. And he goes, "What are you doing?" Because it did look a little immature that I was sitting there coloring. I go, "I'm trying to find a triangle in this figure." He barely glanced at it and goes, "There it is." And I'm like, I have been searching for this for like an hour, and you take a glance. And it's a really good illustration that research has suggested that with these really complex kinds of geometric forms like that males tend to be better at finding the elements than females are. That in that kind of circumstance where it's these geometric, kind of ambiguous shapes mixed in and you're supposed to find them, on average, males are more field independent and females are more field dependent in that kind of testing. If you take them out of that kind of testing and put them into like this little comic testing that I'm showing you here, there is no sex difference. So if the context is stuff that is familiar and real world, you don't see sex differences in field dependence, independence. But if it's this abstract thing that I was trying to color, we see sex differences in that. But what's the difference? If you're a field dependent or field independent person? Well, it turns out that people who are field dependent oftentimes can see the themes that are present, oftentimes are better at interpersonal behaviors because they can kind of see both sides of what's going on because they see the context. Whereas people who are field independent oftentimes are really good at analytical things, things that require attention to detail, those kinds of things, but have a little bit less success at integrating all of the details together and making sense of it. They are not as good at interpersonal things on average. And so, each of them have their benefits and each of them have their deficits that go along with these ways of thinking. One of the ways that I memorize field dependent from field independent is that a person who is field independent can't see the forest for the trees. They're so busy looking at each of the individual elemental trees that they never really back up and go, wow, this is a really dense forest, or this is making up a whole. A person who's field dependent can't see the trees for the forest, right? They're so busy noticing that it's a forest and what that means and how that looks and whatever that is, that they don't even really pay attention to the elements. So that's a kind of a simple old, what is that, a little old saying, not being able to see the forest for the trees. That does kind of line up with these two cognitive styles. How about different types of reasoning? A lot of times, the things that we teach kids in school demand a type of reasoning called convergent reasoning. In this type of thinking, the learner or the person who's trying to solve a problem or whatever, they're given a prompt, and then they're supposed to find the one correct answer. So for example, on a kid's test, they are shown these little diagrams, and it says these diagrams show different trials that Abdul carried out with carts having different sized wheels. They don't mention in this little setup that also the ramp has different slope. So they didn't mention that, but I will attract your attention to that. He started them from different heights, and the blocks he put in them were of equal mass. So he wants to test this idea: the heavier the cart is, the greater its speed at the bottom of the ramp. Which three trials should he compare? So the answer, so you're not going to stare too hard and worry about it, turns out to be S, T, and U, where the ramp is at the same slope, right? And in the far left, the cart's empty. The middle, he's got one block, and in the right, he's got 2 blocks. So the wheels are the same size. In this diagram, the gray wheels are supposed to be a different size than the white wheels. In the top panel, he's got one block underneath the ramp. In the middle panel, all of them have 2 blocks under the ramp, and in the bottom 3 blocks. But the reason why the answer is the middle row is because that's the only row where the 3 carts have the same size wheel in all 3 panels, in all 3 examples, and then all he's doing is changing the mass. So you're given a prompt. Your job is to find the one right answer. And even though a learner might make an argument for a different answer, well, I mean, I would do this or that, there is one objectively right answer, right? And that's the key thing with convergent reasoning. When I was working on my master's degree, I worked with John H. Doolittle. He was one of the professors at my university. Well, he was developing these Dr. Do-riddles. It's already bad enough that his name is Dr. Doolittle, and then he had to tweak it a little bit more and make it Dr. Do-riddles. And he wrote these riddles. Here's an example. I cover that tree, I cover that log, or else I'm a sound that's made by a dog. What am I? Well, the answer is bark. He has a whole bunch of these riddles, and what he was trying to teach children is associative reasoning. He was trying to teach them to take the clues that are provided and come up with the one right answer. That's a measure of convergent reasoning. I got to test out 3rd graders on their ability to answer these riddles correctly, and then he used that normative data to help him to figure out ways to teach them to think more sophisticatedly in this associative reasoning way. In all these examples, you have one right answer that the person's supposed to figure out from the prompt. That's different from divergent reasoning, which is where you have a prompt, but your job is to find various viable responses. So I've given you some kind of stimulus, and you can come up with any answer that you want or any number of answers that you can generate. So I might say, think of all the things that you could do with a paper clip. And then you come up with all the answers. You could make a fish hook. You could straighten it out and use it as a hairpin. You could hold your pants together after the button pops off. I mean, a whole bunch of different things that you could potentially say as an example of a response to what could you do with a paperclip. So in school, we do a lot to teach convergent reasoning. And most tests are dependent on convergent reasoning, right? I mean, most tests want to establish whether the child has learned the thing, the concept, the definition, the steps for the math problem. We want to see that they've gotten the correct answer. Divergent reasoning, we oftentimes encourage when we're having like a discussion, and we try to encourage people to come up with different ways of looking at things. But it's a different process. Divergent reasoning is a different process than what we typically do in school. So a lot of times people think about divergent reasoning as being an example of creativity. So creativity is defined as generating original and useful responses. A lot of times people think of creativity being purely artistic. And yeah, people are creative in the arts, right? But if you think about it as a cognitive task, we're talking about generating original and useful responses, coming up with new ideas. For a long time, people thought that you had to be really smart to be creative, and come to find out that having an IQ score that's greater than 120, which means more than one standard deviation away from the mean, is not necessary, and in fact might inhibit creativity. It depends on what field we're talking about. Like, the average engineer has an IQ that's greater than 120, and they also tend to be highly creative on average. So it's not that IQ interferes all the time with creativity, but you definitely don't need an IQ above 120 to be creative. Generally, you need an IQ that's greater than 85, though. That's one standard deviation below the mean. So really, it seems like the most creative responses tend to come out of people who are between 85 and about 115 on an IQ test. But again, depending on the field. One thing we do know is that creativity is sprung from divergent thinking, and because formal education spends so much time talking about convergent thinking, we try to teach you to ultimately be able to reason your way to the same conclusion that previous researchers or whatever have arrived at. We're trying to get you to think the way other people have thought. And so we may be actually inhibiting creativity. So what I'd like you to do to finish up this chapter is to watch this video where they talk about creativity and education and those factors. And I think you'll find it really super interesting. So enjoy that video, and then I will see you next in chapter 13.